Thank you, Chris, and thank you everyone for joining tonight. It's actually a very wonderful and weird experience to sit here in the darkness in my office and speak to people from around the world and from around the country. But it's a great privilege, and I look forward to share with you tonight some lessons that we've learned and some surprising observations that we had during the drought in 2015 and 2016. And I think this talk comes at a very opportune time because you need to also see what happens after a drought to really understand what the effect of a drought was. So some of the work I'm going to present tonight is work that got published earlier this year, so it's really fresh off the press. And I'm trying to have a lot of pictures in the presentation, but also a bit of science. So I hope that it will appeal to a broad range of people. So not knowing who exactly will be joining tonight, some people have lived in the park and it's got a very intimate knowledge of the park, and other people listening tonight might never have been to the Kruger Park. So I decided to just introduce the park with a couple of slides, and this is usually where people would put up a map. And I love maps, but I thought tonight I'm not going to put up a map. I'm going to start with a painting by Wilfred Chitsangu. And in this painting, I'm going to try and give you an introduction of Kruger. So Kruger is about 1.9 million hectares. It's in the north eastern part of South Africa. It's got a great diversity of plants and animals, over 2,000 plant species, over 150 mammal species, but then there's also a lot of other interesting things in the park, close to 400 spider species, etc., and also the biggest free-ranging white rhino population in the world. But that's not all that Kruger is about. Kruger is also about giving people access to the park to share in this wonderful biodiversity and in the wonderful environment and for their well-being. Actually, there's more and more work showing the important well-being for people coming to parks. And this is also a very important part of the financial model. About 80% of the funding that supports conservation in South African national parks are provided by tourism. But that's not the end of this story. The park is not an island. The park is actually within a landscape where there's other people living. We've got lots of neighboring land uses. We've got communities, rural communities. We've got urban communities. We've got farming communities, all living next to the park. And the park wants to be relevant for these people and want to share benefit with these people. So this is really a very short introduction to Kruger. But this is really what Kruger is about. It's about conservation and biodiversity and ecological integrity. It's about access for people and generating funding through tourism to support the conservation mandate. And it's about the people outside of the park and the social relevance and the benefits that they can share from the park. So this is really just a brief introduction to the Kruger National Park. So in 2015, 2016, we had a very severe drought hit the system, all aspects of this system. And that's what I would like to talk to you about. So just a brief background to the drought and where it occurred. You can see the map here. This map shows the intensity of the drought. So the darker red it is, the more intense the drought. So the more the rainfall differed from the long-term average. And the darker red is with the higher impact areas. And for those of you that know the park, you will notice that it's about from Olifant's Rest Camp right down to Lower Sabi and Skakuza, where the drought was at its most intense. And in fact, at many of these weather stations like Satara, Nuanetsi, and even Skakuza, the lowest recorded rainfall on record was measured during the 2015-2016 drought. In Satara, it was less than 150 millimeters, and in Skakuza, it was the first time under 200. And people always ask about the rainfall during droughts, but that's not the only thing that one should be wondering about droughts, because droughts often is associated with very high temperatures. On this slide, I show you the number of days above 40 degrees. Okay, everyone was talking about how cold it is in the Cape and in Pretoria. But let me tell you, it can get uncomfortably hot in the Kruger National Park. And in 2016, as you can see, there were 24 days above 40 degrees centigrade. So that's much more than many of the previous years. Something that is quite disconcerting on this graph here is that you can see that many of the hottest years that we've had has been in the past 10 years. The bars that are hashed and not colored in fully is years where the weather station had a couple of days problems. So that's the minimum days of at least 40 degrees that this graph shows. So with a lack of rainfall and very low rainfall as seen in those maps, and very hot temperatures, these are the type of scenes that people saw in the Kruger National Park during the drought period. In the foreground, you can see there's hardly any grass, and in the background, you can see the grass that are there is grey and moribund, and really nothing much to forage on for the animals. There was also animals that were in weak condition and that was really trying hard to eat a little bit of food that was around in the landscape. River levels were quite low, as you can see in the background of this photo in the Letaba River. Dust storms, and also animals that died during the drought. Here you can see an example of a hippo. Hippo and buffalo were the two species that were mostly affected. So these are the scenes that one typically see and hear and think of when you talk about and think about a drought in a protected area like the Kruger National Park. And with the Kruger National Park being quite a prominent and a iconic protected area, this obviously grabbed the attention of the media as well. And these are just a couple of the online articles that was published on the Kruger Park during the drought. You can see the titles of the stories here. What I want to point out here is look at the words that people use to in the media to describe the drought: bleak, killer, ravaged, devastating, crises. Okay. These are very emotive and very negative words to describe the drought with. And seeing those pictures, one's maybe not surprised. The other thing that's interesting from many of these article clippings that I have on the screen is that it's all about the animals, the game, and the wildlife. So what I want to do in tonight's presentation is to really show you a bit of a different side to a drought as well, and hopefully provide a bit of a different perspective to droughts. Yes, of course, it's a time of suffering, and it looks hot and harsh out there, and it is, but there's also a different perspective that I think as conservationists and people that's passionate about conservation, we need to be aware of as well. So here is a fixed point photograph that one of our rangers took in the Nuanetsi section. And you can see the top photo is, if I can call it, without drought, and the bottom photo with drought. Okay, but what will you think if I tell you that this was actually the real order in which these photographs were taken? Suddenly the drought looks a bit different. And if I put the dates on there, These photos were taken less than 3 months from each other. In fact, 2.5 months between these two photographs. So this brings me to the first key message of tonight's presentation, and that is that savannas have evolved with droughts. Okay, savannas are adapted and used to droughts. If you look at the landscape at the bottom, and considering that that was 2.5 months taken after the first photo at the top, it's clear that this is not the first time that this area gone through a drought. It's able to quickly respond to it. This is a graph that sort of makes the point even further. It's great that Nick Zambatis is joining us tonight, because he prepared this graph a couple of years ago, and we just continued adding data to it. And this graph shows on the axis at the bottom the rainfall data for the Kruger National Park from 1910 up to the 2015-2016 drought. And on the y-axis, on the bars that you see, is the rainfall. So basically, every time the bar is above the line and it's green or blue, it means that we had more than average rainfall in that year. And if the line is below and it's orange or red, we've had below average rainfall. So what you can see here is that wet and dry cycles are natural to the system. And even the 2015-2016 drought, that was a very severe drought in the central parts, you can see that there has been previous examples as well, or previous years where there was also very, very dry conditions. So that's really the first part of this talk, is just to say to people, if there's a drought, it's not a crisis, it's not something new. It's something that these savannas are adapted to and are well accustomed to. The second message that I want to share with you tonight is that drought is selective, and that you have winners, losers, and, for a lack of a better word, don't carers out there. If you look at this photograph that I've picked to show this key message with, or start this message with, you can see that the buffalo there that was emaciated and in a very poor condition that were caught by the lions clearly are a loser during the drought period, but the lions are probably not too unhappy about the situation. So here is just to show you some of the data to go with this. On this graph that I've got the red pointer up with now, you can see the buffalo numbers with this solid black line, and the hippo numbers with this dashed line at the bottom. And they're on different scales. So here it talks about the buffalo density, and here it's the hippo density. Don't worry too much about the scales, just look at the pattern. The gray bars show the periods when we had droughts. So what you can see is these periods when we had the droughts, there was quite large drops. Look at the buffalo here. In the 91-92 drought, the buffalo numbers dropped from about 30,000 to 14,000, okay? And that might come as a shock, but look at what happened afterwards. They increased up to close to 40,000, I think 38,000 just before the 2015-2016 drought, and then it dropped again. So the drought is really a regulator of these species numbers, and even though the species loses during this period, look at the incredible recovery afterwards. But then there are other species, for example, this guy at the bottom here. You can see I actually took this photo on my way to Chokwan, and it was a group of 3 lions that caught a hippo. And the next day as I drove past, they've caught another hippo, something that would really happen. And here you can see the effect from 2015, the year the drought started, to 2017, the year after the drought. And really you can see the lion numbers didn't decrease at all. It's notoriously difficult to count these animals, but it doesn't seem like they've been negatively affected. Here are some other predators. You can see the hyena data at the top. You can see from before to after the drought, it seems like their numbers actually went up. And then this graph at the bottom here, it's nice that Gus is joining us tonight. This is some work that he and collaborators did a couple of years ago, and which shows that there's a negative relationship between rainfall and wild dog population. So in fact, the drier it is, the better it is for wild dog, which is one of the most endangered carnivores in Africa. So already you can see that drought have a role to play here in these systems. Because if it's every time a wet year, what about the wild dogs? But it's not just about the animals that there's winners and losers. And this is really one of the most exciting results that's come out of this past drought, which I think will be surprising to some of you. It certainly was for me. On the left-hand side, you see a photo that was taken in the Satara landscape. It looks green. You see these tall grass. It looks pretty good. But the grass that dominates there is called Bothria cloa. Okay. So Bothria cloa's Afrikaans name is stinkgras, okay, stinking grass. It's a very aromatic grass and the animals really don't like eating it, and it's a grass that burns and just come back. And there was a research team that looked at this grass and they put up these little exclosures, as you can see here, to actually try and keep animals out and see if the Bothria cloa, the stinkgras, would reduce, but it didn't. And they tried different fire treatments, but nothing actually made the Bothria cloa go away. And it just remained the dominant grass in the landscape. And they looked at this for a couple of years, and then came the drought. You can see in this photograph in the middle, and suddenly the Bothria cloa and all the grass died. And the question is, what was going to happen afterwards? And this is what happened afterwards. Afterwards, forbs, especially in the first year after the drought, dominated, but also palatable grass like Eurocloa mozambicensis, and then also other grass species that came in. So what the result from this study was very surprising, and they found the same result actually in Shishluvi and Umfolozi Game Reserve during this drought. And another study by colleagues of mine in Kruger that looked at different areas in the park also found similar results. So you can see that quote from the one paper. So what's really quite interesting is the drought actually changed the grass from not very palatable for the animals, from stinkgras to Eurocloa, which is a much more palatable grass species. Sally Kerner, who's one of the researchers on this project, kindly shared this data for me for the next couple of years. I want you to quickly have a look here. This red line here shows you the proportion in the landscape with Bothria cloa, with the unpalatable grass. And this orange line at the bottom shows you the palatable grasses, the grass that the animals like to eat. And you can see Bothria cloa was the dominant grass. And then when the drought came, here with the red bar, Bothria cloa just dropped out and the palatable grasses increased. This is for an area that burns every year around Satara, and this is for an area that burns every 3 years in Satara. So isn't that surprising that the drought actually changed a landscape from this type of grass to this type of grass, which is more palatable for the animals? This, of course, doesn't happen everywhere across the park, but there are these landscapes where after the drought, it was actually a much more nutritious forage layer for the animals. So we've talked about the winners and losers for the animals. We've talked about the winners and losers for the grass, and it's the same for trees. This is another work that was done, and I know the Swimmer family is also listening tonight to this webinar. This is work done by Tony Swimmer looking at the mortality of some tree species in the park. You can see the list of species. Don't go through the detail or worry about the detail. What I want to show you here is that there are some species that had a lot of mortality in certain parts of the park. But then these other species which really had very, very little mortality. So this tree here is called Dicrostachy cinerea, or siekkelbush. And they considered an encroacher species. And here you can see this tree didn't do very well during the drought. In fact, in this study, they found that the mortality rate was over 50% in the sites that was visited. But look at this graph, this photo at the bottom with the apple leaves. You can see they in leaf, they're very green, and they really don't seem to care too much about the drought. You can see there's no grass left, but these trees are really not seemingly affected. And again, this might be a positive effect of the drought. Dicrostachys or sickle bush is a known bush encroacher. So bush encroachment is when an area becomes thicker and thicker with one species of bush. It outcompetes the grass. It's really a big problem in South Africa, especially in the cattle farming areas. And this tree is pretty resilient to fire. It also doesn't care too much to be browsed. But look at what happened in this landscape during the drought. Look at all these gray trees, which is sickle bush trees that either got killed or at least stop killed, meaning the top part of the tree died and the tree will now have to resprout from the bottom. So isn't it, again, an interesting positive outcome from the drought that what fire cannot do and what herbivores cannot do, maybe a drought can do. So similar to the stinkgrass, maybe the landscape becomes dominated with some species and then a drought pushes it back and gives other species an opportunity to come in again. And then in the wetter cycle, the balance would shift again. Okay. So that was the second key message. Now we get to the third key message. And again, this is something that might surprise some of the listeners tonight, and that is animals die due to lack of food, not due to a lack of water. And in fact, if you provide too much water in a landscape, that can actually be detrimental. So this might sound a bit counterintuitive, that water can be bad for animals. So let me try and explain this with a very simplified, probably oversimplistic representation of how this works. But I think it makes the concept quite clear. So on the left-hand side, you can see a landscape with a lot of water holes. Let me just, and let's think about this brown area around the water hole as the area that the animals graze. Okay, so the animals would stay around the water hole, eat the food there, and be quite happy. Food and water is available to them. On this left-hand side, there might be more animals because there's a lot of water and a lot of food, as opposed to the right-hand side. But then, as the drought continues, the food will be finished here, even if there's still water, and the animals will have to start moving further away to get to food. And as the drought continues, the animals need to move even further. So what you can see is, in this situation, the water can still be there, but almost the entire area has been grazed. Whereas on the right-hand side, with the area with a low density of water, there's still food available for the animals that can travel far, or the water-independent animal species. Remember, not all animals are as water-dependent as some other species. So what will happen in the left is the animals will die because there's no food. Or the animals would actually move from that area with the high density of water holes to the area with the lower density of water holes. And in fact, we had a situation where we could test it to some degree during the past drought with some of the private reserves adjoining the Kruger Park having quite high densities of water holes as opposed to the Kruger Park. And if you look at the data on the screen now, you can see that the buffalo population in the private reserves dropped by 70%, as opposed to the areas directly adjoining those private reserves in Kruger, where the buffalo population dropped by 49% and 20% respectively. You can also see the grass biomass in the private reserves was much lower, 350 kilograms per hectare, whereas in the Kruger National Park, in the central and northern Kruger National Park, it was quite a bit higher. It's most likely because a lot of those buffaloes in the private reserves moved into the Kruger area as the forage there was finished. This is just to show you some photographic evidence as well. You can see this hippo is incredibly thin. It's grazing on the little bit of greenery that grow next to the road because of the runoff of water from the roads during the drought. And this hippo is grazing in broad daylight, something that they would typically not do. They would only graze at night most during normal rainfall years. Also, look at these incredible photos that one of my colleagues took in the Pioneer Dam around Mupani Rest Camp, where you can see these two buffalo bulls going deep into the Pioneer Dam to eat water lilies. And these animals are actually grazers, they eat grass. And water lilies are really it's not something good to eat, but these animals were just so thin and so desperate for food. So they actually went deep into the dam to go and eat water lilies. And on the bottom left, you can see a buffalo also browsing on, I'm not sure if it's a red willow or a mupani tree. So really, this is some indication of the fact that the animals really died because of the lack of food, not the lack of water. But we stay with water, and I want to get to the fourth key message, and that's about rivers and river management. So you can see the Kruger National Park here on the right-hand side, and this is the Crocodile River, one of the perennial rivers running on the border of the park and in the park. But where do you think this water comes from? This water comes from the river up here and from the mountains around here. And this water runs through plantations, it runs through rural villages, through towns, through sugarcane farms, etc., before it comes to the Kruger National Park. Okay, so we cannot start conserving the water once it gets to Kruger. We must make sure the water gets to Kruger. So in my opinion, this is one of the most important conservation maps that has been published in South Africa in the past couple of years. It's a map of the strategic water source areas in South Africa. So take a moment, we're stepping a little bit away from Kruger now, but this is so important that I feel it provides very important context for what I'm about to say. This shows 22 areas in South Africa representing 8% of South Africa land surface, okay? These areas generate 50%, 8% of South Africa generate 50% of all our water. It sustains 51% of our population. It supports 64% of our economy. And here is the shocking part, only 13% of those areas are conserved, okay? So these are our water factories, and this is really the areas that we need to look after. Thanks to a colleague of mine, Eddie Riddell, for calculating these for me that I'm showing you on the screen now. This is in the little box that appeared now is the 5 perennial rivers of the Kruger National Park. And the percentages you see there is actually the amount of water in that river that would have got into the river if it was just for the catchment within the park. Okay, so let's look at the Olifants River. If only the water in the catchments of the Olifants River within the Kruger National Park made its way to the Olifants River, we would only have 1.8% of the water in the river. Okay. So the point I'm trying to make here is that Kruger have beautiful rivers, but we need to conserve our rivers outside of the park. And that is why sandparks actually employ people to work outside of the parks and to work and to engage with water users outside of the park and catchment management agencies, etc. So how do we manage rivers in the park? This is a graph that Eddie Riddell and Jacques Venter, two of my colleagues in Sandparks, kindly provided. Let me quickly show you here. So so these horizontal lines show you when we get worried in the park, okay, for a specific volume of water. So we've got what we call a low worry level, a medium worry level, and a high worry level. The blue line is the flow. So every day, a colleague of mine check the water flow in all 5 of the perennial rivers in the Kruger Park using the Department of Water and Sanitation's gauging weirs. So it's an online system and it checks the flow of the river. If this flow goes below these worry levels, then there's some sort of action that happens. In this case, you can see that the Department of Water and Sanitation was contacted about at the Nandoni Dam to ask for some release of water from the dams upstream of Kruger. Okay, and a couple of days later, the water arrived at Kruger, and you can see that the flow in the river increased again. Okay, so this is example during the drought of some engagement with people outside of the park. And we've got a lot of important stakeholders like the Catchment Management Agency, the Department of Water and Sanitation, NGOs like Award that's been doing amazing work in the low-felt rivers, especially the Olifants River, to ensure that the water flows in the river and that appropriate restrictions is applied. And not restrictions that's bad, but restrictions to make sure that water is conserved for everyone that's dependent on the ecosystem, the rivers, the biodiversity, but also the people and the farmers and the communities living next to the rivers. This is just showing it in a pictorial way. You can see this is a picture taken from the same location. You can see this, this rock on both photographs. This is the Olifants River during October 2016. And here, there was less than 0.4 cubics of water per second flowing in the river, in the Kruger National Park, in the Olifants River. And again, through Award, the NGO, and through Sandparks and the Department of Water Sanitation and a lot of other stakeholders, water was released upstream. And look here, the river started flowing better again, okay? And this was actually one of the real positive stories from the drought, was that people always say there will be wars fought around water in the future, but the rivers in some cases actually acted as a catalyst for people to talk to each other and realize we're in this together and we all need to manage these rivers for the betterment of livelihoods of people, commercial farmers, subsistence farmers, people fishing in the rivers next to the park, and also for the biodiversity in the park. And I get to my 5th and final message, and that is just a little fun section on nature is full of surprises during drought. Thanks, Gwen, for the lovely introduction and also for the lovely photograph that you've provided me with. This photo is of Crinum minimum, a veld lily that Gwen took on the Pabeni Road. I think she and Nick went out there, and this is a very interesting flower. It flowers at night. It only flowers for 1 or 2 days, and then it produces 1 to 3 seeds. And it makes use of nighttime pollinators, probably moths, because it's a very fragrant plant. But what's really interesting about this plant is that this plant has only been seen to bloom in the park 3 times up to the drought. So during this period of the drought, and when the drought was really at its most severe, suddenly these flowers started emerging. That just shows you that this plant don't really think about the drought exactly the same way as we think about the drought. Of course, it's very hard to attribute it to the drought. Maybe it's not because of the drought, but maybe it is. Maybe it's just the good conditions for these plants to push these flowers. It's a bulbous plant. This was a very interesting phenomena that we also saw in the year just after the drought, and that was these massive flocks of red-billed quellias. In the year after the drought, it was literally for 30 to 40 minutes late in the afternoon, the sky around Skakuza and also the areas in the central Kruger Park around Satara would just get filled with these birds, looking like locusts almost, and they would be swarming around. And we've got some ideas on why this might have happened. But this has never been seen. We do see these flocks, and it has been recorded during previous droughts, but never to this extent. So again, this species seemed to have benefited in the year after the drought, as you can see from these massive flocks. And then the thing that Gwyn mentioned at the start, and this is a bit of a personal story, but this is something that we discovered during the droughts. As we were hiking, we walked from the north to the south of the park, and we came to the Shingwetsi River, and these beautiful rock formations you see here is in these Clarence Red sandstone formations called red rocks. And these rocks were filled with water. It's actually in the river. And we wanted to cool down a little bit and put our feet in there. And as you do in Kruger, when you want to cool off in a river when you're hiking, is you first check whether the pool is safe so that there's not crocodiles or anything in there. And as I was looking into the water to see if it was safe to put in my feet, I saw something that looked very unusual to me. And I said to my colleagues, there are some jellyfish in this pool. And of course, at first they thought probably that I was a bit, that I have sunstroke. Jellyfish in the Kruger National Park during a drought. And lo and behold, we used our cups and we caught a couple of them. And you see a photograph of them here. They were bright green. They go into a mutualistic association with savanna bacteria. And with some colleagues from the Albany Museum, we've now done, and Rhodes University and SAAP, we've done genetic analysis on them. And it seems to be the Great Lakes jellyfish, which is a freshwater jellyfish that mostly occur further north in Africa. That's why it's called the Great Lakes jellyfish. But it made its first appearance in the Kruger National Park during October 2016. Okay, after all these years, the first time we saw them. And it's really an exciting find because it's not just a new species for the park, it's actually a totally new phylum for the park. So within this phylum, you find anemones and sea corals, etc. So who would have thought in the drought that we would discover a new species and that new species would be freshwater jellyfish? I didn't, to be quite honest, even know of the existence of something like freshwater jellyfish. So I want to end off. If we think back about those headlines in the newspapers during the drought, talking about droughts being devastating, killing, ravaging, bleak, and crises, is it the case? Well, for the species on the left-hand side, like buffalo and hippo and sicklebush and stinkgrass, it might be the case in the short term, but only in the short term. They bounce back during the wetter years. For the species on the right, like Eurocloa and the jellyfish and crinum and apple leaf and lions, they don't care, or they might even be benefited. And what you can understand is if we just have wet years, what about the species on the right? If we only have dry years, what about the species on the left? And that's why you need this sort of cyclical nature of wetter and drier periods to keep the system resilient and make sure that the system don't just go to the one side or to the other side if you think about the schematic. So the wet and the dry periods are quite important. So I want to end off with this photograph of the of the Kruger savanna. And I want to leave you with a metaphor. I was trying to think of a way to describe the drought. And I want to say, use the metaphor of a symphony. So next time you see a savanna landscape like the one on this photograph, think of a symphony, this beautiful symphony of trees and grass and animals. And then think a little bit about what are the instruments that make this symphony so beautiful. Why is it not just trees? Why is it not just grass? What is making this such an interesting mosaic of trees and grass and animals? And the instruments here is soil, it's rainfall, but it's also fire, it's also herbivores, it's also elephants, and it's also droughts. And I think the droughts are like the bass drums. If you think about the 1812 overture of Tchaikovsky, the cannon shots, maybe the drought is like the cannon shots in this symphony. You don't use it too often. You don't want to play the cannons all the time, but it really is part of what makes the savanna a savanna and shaping this system. So thank you very much for listening, and I hope it gives you some other perspectives on the drought, and that you would be able to come and join the Savannah Symphony again soon as the lockdown ends and you can come and visit us again in Kruger. Thanks, Johan, back to you.